Welcome back, dear friends. Today's video is going to be very simple. We're going to build a Joule Thief circuit with only 4 parts, 4 simple parts. These are the parts right here. This is all you need: an LED, a resistor, a transistor, and an axial inductor. That's all you need, my friends. Joule Thief for Dummies. This is for me. Okay, so the first major problem that we're going to tackle with this new type of Joule Thief circuit is the fact that all Joule Thief circuits, as I like to call them, use toroids. This is actually one of my first builds. When I finally managed to make it work, it was like a eureka moment. These toroids include unnecessary variables in the circuit. They are big, bulky, and depending on the material that they are made from, you need to wind a particular number of turns to make that LED oscillate. So today we eliminate all of those frustrations that I had while building. I've tried many toroids, big, small, even smaller. They did not work because the transistor would vary, the number of turns you need to make on the toroid varies, too many variables. So today we eliminate all of those things and we replace them with this. This is my type of mini transformer. This is my invention, let's say. It's an axial inductor with some copper wire winded on top of it. We have a fixed axial inductor. This is a 220 microhenry axial inductor on which I've winded 32 copper turns. Standard. 220 axial inductor, 32 copper turns. Works brilliantly. No more headaches, no more toroids, no more variables. This is why I'm so-called the video Joule Thief for Dummies. It's a standardized way to make a circuit that works from the first try. At least from the first try. If it doesn't work from the first try, I will show you some quick tips. There are only 3 troubleshooting steps that you need to go through, and the circuit will work for sure, guaranteed. For the parts list, we only need a small 220 microhenry axial inductor and some copper wire, just enough to make 32 turns, a 1 kilo ohm resistor, a 2N.2222 transistor. I'm using a 2222A transistor, it's slightly better, and a white LED. Another advantage of this circuit is we can make it really small. As you can see, the pieces are really small compared to my finger. This will come in handy, as you will see. As for the wiring diagram, this is how it looks. Very simple. This is the correct schematics. Just follow the connections and solder them properly. I have some thin wire here. The thinner the better. You only need about 30 centimeters, not more. I recommend soldering it on one side. So let's scrape off the enamel. Okay, when it's shiny like that, you know you've done a proper job. So we've fixed our wire. And now we're going to go from the silver line, 32 turns on this axial inductor. And we're going to go clockwise. If it does not work, so 1, 2, we're going to go counterclockwise if it does not light up. 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 17, 18, 19, 20, 21, 22, 23, 24, 25, 27, 28, 29, 30, 31, 32. 32 and 1, 2. Okay, just to tie it up really nice. You can add a dash of super glue or some nail polish on it just to make it stay while you're building the circuit. Okay, regarding the transistor, the way I remember the legs, when the flat side is facing you, emitter, base, collector. It's instead of ABC, it's like EBC. We're gonna put it in our support. And our LED, the small leg is the plus side, and the one with the big flat part is the minus side. So minus side goes on the emitter and the plus goes on the collector side. Now your resistor always goes to the center. The axial inductor goes to the resistor. And the thin wire goes to the collector. Now let's give it a test. So plus goes to your axial inductor and minus goes here. And it doesn't work, and I will tell you how to troubleshoot this. This is actually good that doesn't work from the first try. The first troubleshooting steps that you could do is move this to the collector. Okay, and the thin wire, solder it on the resistor. Now let's test again. And it does not work again. This is very good that it does not work. So the next troubleshooting step that we need to do is we need to wind this in reverse. So we've wound it clockwise. Now we're going to wind it counterclockwise because the magnetic fluxes repel each other instead of attracting and creating an induction. So let's do that. Let's rewind this inductor and finally it should work. Now we're going to unwind. So we did wind it clockwise. Now we're going to go counterclockwise. Just unravel it and do it counterclockwise. This is why this video is called Joule Thief for Dummies. I made it for myself mainly because I would always forget how many number of turns, how to do clockwise, counterclockwise. And now you've seen all of the failures that can happen in this video. So now that you know what can happen and can go wrong, we can fix it. So now let's go counterclockwise, 32 turns, okay? 1, 2, 3, 30, 31, 32, 33, 34, 35 on the dash. Now let's put it back on our circuit. I want to make sure I solder it correctly the first time. And let's put this one, the thin wire here. So now that we've placed it correctly, works perfectly. Super. Now all we need to do is make our circuit really small and put it in our casing for a super bright flashlight. Yes! So, one other advantage as opposed to big and bulky toroids is that using an axial inductor you can make the circuit really small, small enough that you can fit it inside of a syringe head, as I did in my previous video with this underwater flashlight. Yeah, works brilliantly underwater, no problem. And the light is really powerful, yeah? This is pretty bright. One other advantage is that you can use half-dead batteries with this circuit. Let's take this headlamp. I have 2 batteries. These are half-dead batteries. So let's place them inside. Minus. And let's light it up. Now let's see how much it goes. So it will go for a few seconds and then it will die out because I've tried these batteries previously. And You can see the light coming from it is close to zero. Look, I mean, this is not usable light. It will barely, this is barely reading light. This is not usable light. So let's take the batteries out. Yeah, let's take one battery out. We only need one. Yeah, let's place it inside our circuit. And what do you know? Well, this really is usable light, as you can see. So I've made a little test rig for our circuit right here. And for measuring purposes, we have two batteries. When I switch to the half-dead battery, let's see what the voltage is on this one. Half-dead battery has 1.3 volts. And the full battery has 1.6 volts. Let's measure the amperage on them also. So let's see the half-dead oh, what? So you saw on when we do a short circuit on the full battery, we have almost 2 amps. You could see how fast that went. And on the half-dead battery, let's see what's the short circuit. It's 500 milliamps. So that battery is really close to being dead. So you've seen how big of a difference is between a full battery and a half-dead battery. The dead battery gives only 500 milliamps, even less, 450 milliamps, yeah? So let's see on this half-dead battery how much light we still have. Yeah, so you can see it's still really bright. This is on the half-dead battery, but I also wanted to measure out the voltage. What am I doing wrong? Yeah, I know what was wrong. I did not put it on the voltage reading. It was still on the amperage reader. That's why we had that flicker. Okay, now we're testing it properly. So on the amperage, on the half-dead battery, the one that gives off 450 milliamps and 0.78 volts, you can see what's the voltage on it. The current draw is about 90, close to 100 milliamps. That's the current draw. So even with this small amount of current, you still have usable light. You can still get your way through in the dark with this light. And if we switch to full, yeah, it's a blowtorch. The amperage, the current draw is 160, close to 170 milliamps if you look at the amperage reading right here, and the voltage is 1.45 volts. Yeah, and this is under load, 145 volts. From this to this. This is why this circuit is so useful. It uses all of the energy from the battery. For emergency flashlights, this is perfect. We're going to have some amazing flashlights just with this little circuit. This is the foundation video for a whole new series. I'll see you in the next one, my friends. Like and subscribe.